We're going to start talking about systems of equations. So far we've been talking about linear equations that have two variables. We've talked about point slope, slope intercept, etc. In systems of equations, there are two linear equations that are solved together. Actually, there can be more than two, but most of the problems we do will be two linear equations with two variables. This means that they describe two linear relationships that are being compared or analyzed for possible similarities, etc. While the solution to a single linear equation is the set of all ordered pairs on that line, or that satisfy the equation, the solution or solutions to a system of linear equations, if there are any, are the ordered pairs that appear on both lines or satisfy both equations. There are three types of systems of linear equations in two variables, and three types of solutions. On the left, we have an independent system. We have then an inconsistent system and a dependent system. These map directly to whether there's one solution, no solutions, or infinitely many solutions. Let's look at how you fill that in. You can see that in the independent system, the two lines cross at a single point. You can clearly identify what that point is, and that is an independent system with one solution. In the second example, the lines are parallel. So by definition, they never cross, and so there are no ordered pairs that are shared on those two lines. So that is no solutions. And then dependent systems are ones where you have two lines which are identical. I've drawn them a little bit skewed so you can see the two colors, but they're actually the same line. As the text here says, they are coincident. They're in the same place. So every ordered pair on both lines is a solution to both equations. When we solve linear equations, there are three ways we do it. We can do graphing, and for that I don't have examples except for what's shown right here. You graph the two linear equations, and if they cross, then you write down the ordered pair where they crossed, and that's the solution. But we do have two other ways to solve equations which are algebraic rather than graphical. Substitution involves the following steps. Solve both equations for y, which these are not. Set the right side of each equation equal to each other. Solve for x. And then plug in the value of x that you solved for into one of the original equations to find y. Now let's have you try this. On your own paper, solve these two systems of equations by substitution. The one on the left is one system, the one on the right is another system. Pause the video and solve them on your own paper. You'll be turning that in later. Okay, now let's move on to elimination. In elimination, there are four steps as well. We write the equations on top of each other, making sure they each match each other's pattern. So for example, these do not match a pattern because you've got x equals 3y and then x plus 2y. The pattern is not the same. So we have to write them on top of each other, but arrange them properly, do whatever adding or subtracting from both sides you need to do to get them in the same order. And you'll see an example in a few minutes. Then you add or subtract the equations vertically to eliminate one of the variables. You can see that if the pattern was matched here, you could just subtract x minus x and you get 0, and then 3y minus 2y and get 1y. You cannot do that here because they're on different sides of the equal sign, but you see the concept. After you've eliminated one variable, there's only going to be one variable left in the resulting equation, so you can solve for that. And once you have the value for that, you can plug in the value of the variable that you just solved for into one of the original equations and solve for the remaining variable. Now you try. Use elimination to solve these two systems. The one on the left is one system, the one on the right is the other system. Add that to the piece of paper you're working on, and when you're done, you can turn it in.